So this video is on areas of triangles. So here we have a triangle ABC like this, and we're going to label the sides and angles the same as we have in the sine and the cosine rule videos, where the side opposite the angle is the lowercase of that letter. So this side here is opposite A, so this is going to be A, this side is opposite B, so it's going to be B, and therefore this is going to be C as it's opposite C. And then we're going to label the angles based on what corner they're in, so this is at corner A, so therefore this is going to be angle A, and therefore this is going to be angle B, and therefore this is going to be angle C. We can find the area of any triangle using the formula, so area is equal to half AB sin C. This isn't given to you in the formula booklet, so you'll need to learn it. So if we know two sides, so let's say this side, and the angle between them, say this side, we can find the area of any triangle. So let's do an example. Here we have a triangle with two sides of length 5 and 7, and we know the angle in between these two sides is 34 degrees. It has to be the angle in between these two sides. Using the formula, we can find the area of this triangle. Now, you can use the labellings if you want to, but basically, in order to just do the area of the triangle, you just need to find two sides and then the angle in between them, and therefore that will give you the area. So in order to find the area of this triangle, the area of this triangle is going to be half A, B, sin, C. So it's going to be two sides and the angle in between. So it's going to be half, remember the half, don't forget that, times and then one of the sides, so 5 times another one of the sides, times 7, and then it has to be the angle in between, so it's going to be that, so times sin 34, and if you put that into a calculator, it is equal to 9.79, and that is the area of this triangle. Now, they could ask you to prove this formula like the sine rule and the cosine rule, so have it in the back of your head how to do it. It's the same technique as the sine and the cosine rule, actually, where you draw this vertical line down here and you create two right angled triangles. And this line here, if you think about it, is actually the height of the triangle. It's actually the height of the triangle. And you should know, hopefully, that the area of a triangle is equal to half times the base times the height. Well, in this instance, the area is equal to the half times the base, which in this instance is B. This is the base of the triangle, so it's half times B times h, which is the height, which we've already talked about. And now we know what b is, but we don't know what h is, but we can figure out what h is because we have a right angled triangle here. Basing it around c, with this is the opposite, this here is the longest side, so it's the hypotenuse, and this here is the adjacent. We don't know anything about a and we don't need to find it, so we're going to cross it out. So we've got O and H, and that is the sin trigonometric ratio, where sin theta is equal to O over H using SOHCAHTOA. Sub the values in, so it's sin, so we're using this angle here, so it's sin C is equal to O, which is H, over the hypotenuse, which is A. Times both sides by A to get A sin C is equal to H. So now we have H, we can sub it into this to get area is equal to half times B times H, which we found as A sin C, which is equal to half B A sin C, which obviously we can write as half AB sin C. So that is the proof that the area is equal to half AB sin C. So using this video and the sine and cosine rule videos, we can now approach triangle questions to a good degree. We can find the area using half AB sine C, and we can use the sine rule and the cosine rule in order to find sides and angles. So you can use these tools in order for you to solve triangle problems, as well as kind of the basic things that you've hopefully learned already, such as SOHCAHTOA and Pythagoras. So here's a couple of questions on area of triangle, so pause the video, have a go, and I'll go through the answers in about 5 seconds. Okay, so for question 1 we need to find the area, so that is an indication that we're going to want to use the area is equal to half AB sin C. However, we have two sides, but we don't have the angle in between, so we can't use that yet. However, we do have an opposite pair of a side and an angle, so that gives us an indication that we can use the sine rule. And what we can do is, because we have this side, we can find this angle here. So because we're finding an angle, we're going to use the version with the angle on the top. Sin A over A is equal to sin B over B, which is equal to sin C over C. So we have the opposite angle and side here, so it's sin 19 over 6 is equal to, and we have the opposite side and angle here, I'm just going to call this angle A, is equal to sin A over 5. Times both sides by 5 to get 5 sin 19 over 6 is equal to sin A, and then if we put this into a calculator, we will find therefore that sin A is equal to 0.271. I'm doing it to 3 decimal places because the question says the 2 decimal places. I usually like to do it to 1 or 2 more decimal places further to make sure that there's no mistakes. And then before we can do the inverse of that, to do A is equal to the inverse, or so sin minus 1 of 0.271, which is equal to 15.724. So this angle here is equal to 15.724, and therefore, because angles in a triangle add up to 180 degrees, we can now find this angle to be 180 minus 19 minus 15.724, which you put into a calculator is equal to 145.276. So now we know this angle is 145.276. We can use the formula area is equal to half AB sin C. We're using these two sides is equal to half times 5 times 6 times sin 145.276, which if you put into a calculator is equal to 8.54. The area is 8.54 to 2 decimal places, and that's the answer. So for question 2, we're given 2 triangles that are joined together in order to make a quadrilateral, and we're given the total area of this shape 28 plus 10 root 3, and we need to find x. So the logical step is to find the area of both of the triangles, and this will be equal to this. And the area of both of the triangles, well, we can figure out this area of this triangle because we have 2 sides and the angle in between, because remember the area is equal to half AB sin C, but we can't figure out the area of this triangle yet because we have 1 side and 1 angle. We would need this side here as well in order to give the area, but we can figure out this side because we can use the cosine rule here because we have 2 sides and the angle in between. So remember that the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos A, where A here is obviously going to be this angle because we're trying to find this side here. So it's going to be, we're just going to call this side A. So it's going to be A squared is equal to 5 squared plus 8 squared minus 2, 5, 8 cos 60, which if you put into a calculator is equal to 49. So A squared is equal to 49, so therefore A is going to be equal to the square root of that, which is 7, so this side is 7. And now we can figure out the area of both of the triangles. The area of this triangle is going to be equal to half times 5 times 8 times sin 60, which if you put into a calculator is equal to 10 root 3. And then the area of the other triangle is equal to half times 7 times x times sin 30, which if you put the half and the 7 and the sin 30 into a calculator is equal to 7 over 4, and that's going to be x. So therefore the total area is equal to 7 over 4x plus 10 root 3, and this is obviously equal to what they give us in the question, 28 plus 10 root 3. Well, obviously we can take away 10 root 3 from both sides to get 7 over 4 x is equal to 28 times both sides by 4 to get 7x is equal to 112, and then divide both sides by 7 to get x is equal to 16, and that's the final answer.